Meanwhile, okay, let's try this again. I think I'll just hold on to this. Yeah. Can you hear me now? Better. Okay, sorry. I'll start again. Yes, for topics 1 and topic 2, you can access that through Moodle. The questions and the solutions for topic 1 and topic 2 are available. If you still have any questions with regards to that, then feel free to come and see me. Today we'll jump straight to topic 3, and that is looking at conversions. I'll briefly look at the metric and imperial conversion, but when we go into tutorial, that's when we'll go into more detail about how to go about with conversions, especially with regards to the two kinds of metric or system units. So with conversions, these are the few things that we will discuss, the two types of system of units, and then we'll look at the rules of metric conversion, the rules of imperial conversion, and we'll also discuss at least 2 examples. The exercise that I've put at the bottom is something for you to try at home. Is that clear? Okay. If you want to download the PowerPoint, I've put this on Moodle, so you can always download that off Moodle at the end of class. But I tried to upload this before the lecture so that if you feel the need to print that out, you can always print that and bring that to class and make notes while in lecture. Okay, so as I've mentioned, starting from this week onwards, I will be taking the lectures and tutorials. Okay, so if you have any problems with regards to the course, feel free to come and see me. All right, so let's jump right into our topic for the day. So with units, metric units is something that we use in our everyday life. You all are familiar with this. If we talk about your weight can be measured in kilograms. Kilograms is known as metric units. So with metric units, we have, if we talk about the length of distance that you traveled from home to come to school, we look at that in kilometers, meters, centimeters, if we're looking at the length of your textbook, and millimeters, if you're looking at if you're trying to measure the point of this pen, it's measured in millimeters. The other quantity that we look at when we talk about metric units is weight. It can be measured in kilograms, grams, and milligrams. Okay, kilograms may be your weight. Grams, can you think of anything that's measured in grams? Your book, maybe. What about milligrams? Pencil, medicine, tablets, yes? All those, they are measured in metric units. Okay, so metric units is what we usually see every day. And then we have volume, when we talk about, say, liquid volume. So kiloliters, we hardly look at, or we hardly talk about kiloliters, but we do deal with liters and milliliters in our everyday life. Okay, liters, you have to drink approximately 3 liters of water in a day, normally. Okay, and milliliters, if we're measuring anything that you can think of that can be measured in milliliters, again, juice. All right, so as I've mentioned, there's 2 types. One is metrics, that's something that we're all familiar with, and then we have imperial conversions. Maybe if you go to Great Britain, they use this type of measurements. So when they talk about lengths, they look at the distance in miles, yards, feet, and inches. When you talk about weight, it's usually in pounds and ounces. Okay, if you listen to people, sometimes they say that I weigh in this much pounds. That's basically imperial units, and they're talking about their weight. Okay, and then the last one is volume. The units that's related to this are usually pints, quarts, and gallons. Okay, so I know that you might be hearing some of this for the first time, but remember that there are 2 types of system of units, and that is metric units and imperial units. So the rules of metric conversion. So generally when you are asked to convert metric units, we say that if you convert from a bigger unit to a smaller unit, you need to multiply. So that's the general rule. From a larger unit to a smaller unit, you need to multiply. So the example that I've given here is change 10 kilometers to meters. Kilometers to meters, we know that from kilometers to meters, you multiply by 1,000. So the 10, multiply that with 1,000, that is equal to 10,000 meters. Okay, so keep that in mind. For generally, when we're talking about metric conversions from a bigger unit to a smaller unit, you need to multiply. The value will depend. Sometimes we use 1,000, sometimes we use 100, sometimes we use 10. Okay? So that's for metric conversion. Metric conversions will use numbers like 10, 100, and 1,000. So if going from a larger unit to a smaller unit means to multiply, it must give you an idea that from a smaller unit to a larger unit, you need to divide. Okay? So it's basically just the opposite. So from a smaller unit to a larger unit, you need to divide. And the example here that I'm giving is change 3,500 milliliters to liters. You divide that by 1,000, you get 3.5 liters. Remember, when you are talking about units, you should use the proper unit. Is that clear? Don't just write 10,000, then I'll assume you're talking about monkeys or dogs. Okay? You have to use the proper units. In liters, you can write L, or you can actually spell out the word liters. Right, so basically just going to browse through. This is available on Moodle. You can always download this off Moodle. And then we have imperial conversion. It's quite different, right? It's very different. If you browse through your books, most of these examples that I've used are basically from your course book. Okay? So for imperial conversion, as long as the number on the left-hand side is 1, okay, as long as the number on the left-hand side is 1, then we can draw a line from left to right. So from left to right, we multiply, and from right to left, we divide. Okay, so keep in mind, imperial conversion, the number on the left will always be 1. So all you need to do, draw a line and indicate that from left to right, it's multiply, and right to left, you divide. But the value will depend. As I said, in metric units, the number that we multiply with is either 10, 1,000, 100, or 1,000. That's for metric conversion. But imperial conversion, it will depend on the conversion itself. Sometimes here, in this case, from left to right, you times whatever number you get on the right-hand side, that means times 3.13. So 1 times 3.13 gives you 3.13. And from right to left, you divide. So you divide by 3.13. So what we're saying here is from meters, if you convert that to feet, you multiply by 3.13. And when we're changing feet to meters, we divide by 3.13. So it's very important when you come across an imperial conversion, the first thing that you need to do is draw these two arrows. Left to right, multiply, right to left, divide. Okay, we're going to have a look at a few examples now, and hopefully by then, whatever I'm talking about here will make sense. All right? So we have the first example, and here it says 1 meter is equivalent to 1.1 yards, and 1 mile is equivalent to 1,760 yards. What type of conversion is given? We have imperial conversions. Okay, so 1 meter equal to 1.1 yards. And what did we say? Left to right times right to left, divide. So what is the value? 1.1 divided by 1.1. That's the first conversion. The second conversion says 1 mile. Like I said, the number on the left is 1. 1 mile is equivalent to 1,760 yards. Again, right to left times 1760, and sorry, left to right, and then you have divide by 1760. So as long as you get the question, this is the first thing that you need to do, draw the arrows. Okay? And then we have, suppose, a question that says, find the number of yards in 800 meters. So we're saying we're changing this 800 meters to yards. Follow the arrow. 800 meters. Which one are you going to use, 1 or 2?
1.
Number 1. Meters to yards. What does the arrow say? Multiply by 1.1. Okay, so 800 times 1.1. And there we have it. 800 multiplied by 1.1, that's equal to 880 yards. As long as you are able to draw the arrows, you will be able to answer the question. Next one, find the number of kilometers in 10 miles. Here's the tricky one. We have miles, and we're trying to convert that to kilometers. Okay? As it is, there's no kilometers here, but we do have meters. So miles can only change to yards according to the conversion. So I can write a flow chart, miles to yards, and yards I can change that to meters. And the meters I can change that to kilometers. Is that clear? When you have a flow chart, it makes things much easier. Miles to yards, what does it say? Follow the arrow. Times 1760. Yards to meters. Yards to meters. Divide by 1.1. What is meter to kilometers? Divide by 1,000. Okay? So keep in mind, when you have problems as such, you draw a flow chart, then only you will be able to answer the question. So this is what we have. We mentioned times the 10, you times that with 1760, that's 17,600. And then we mentioned divide by 1.1, we get 16,000. And then further on we said divide by 1,000. So therefore, we can say that 10 miles is equivalent to 16 kilometers. Okay? If you have a look, in most of my tutorial last week, I've given out the handout for week 3, the tutorial questions for week 3. After today, you should be able to answer those questions. Okay? Maybe you just have tonight because some of you have tutorial tomorrow. All right? Again, you can copy this. This is available on Moodle, and we'll try and get the recording uploaded as well for the sake of your studies. Let's look at another. Now here it says it's a word problem. Change inches to centimeters. We multiply the number of inches by 2.54. Change the conversion into the sentences into a conversion formula. So I times 2.54 is equal to C. And as always, when you have to write C as the subject, it must be given on the left-hand side. So therefore, C is equal to 2.54I. All right? In this type of questions, we ask you to use the formula that you formulated to answer the questions that follow. So it says, use the formula above to change 200 inches to centimeters. 200 inches simply identifies this value, and that is I. You substitute I with 200, you will be able to change that to centimeters. Okay, so I is equal to 200 inches, C is equal to 2.54 times I. That means 2.54 times 200. Your final answer is equal to 508 centimeters. Okay? Sometimes we ask you use formula in A to change 100 centimeters to inches. The unit here is centimeters. That means that's equal to C. All right? Inches, I, centimeters, C. All right? So if C is given, all right, C is given, that means you have to solve for the unknown, which is I. So I is equal to C upon 2.54. That means 100 divided by 2.54. The answer is 39.37 inches. Any questions? No questions? Okay, so please mark these questions here and try that for homework. And from here, what is it? All right, we've used about 20 minutes. If you have no question, then we'll move on to the next topic. Okay, the next topic is 1.4, and that is other calculations. Okay? 2A and B. Number 4, A to C. Try those questions. You can always refer to the lecture to answer those questions. Number 4, it's A, B, and C. Number 2, just A and D. Right, so any questions with regards to conversions before we move on to the next topic? What is the next topic? 1.4, and that is other calculations. Okay, here it's very, very helpful if you have your calculator with you. If you do not have one, make sure you have one when you go into the tutorial. Is that clear? Okay, let me try and change this. Okay, so with other calculations, again, you have the course book in front of you. If you want to go into more details about what I'm talking about, feel free to read through the course book. Whatever I'm discussing in lectures, I'm picking out just the key points so that I'm able to discuss the topic in brief. Okay, so we'll look at the power keys. The power keys that most of you are familiar with are what? Squared? Cubed? Yes? If I asked you to find 9 squared, what is 9 squared? 81. If I asked you to find 9 to the power of 4? Okay, thank you, madam. Stop trying to mess up with my brains. Okay, so this is where the power keys come in. All right, so we'll talk about the power keys. We'll talk about the root keys. We'll also look at a few calculations, and the most important one is simplifying square roots. Okay, this is one of the most challenging subtopics that students face. Okay, so first of all, the power keys. One of the most common one that we look at is x squared. Okay, you all know where to find that. 5 squared is basically just press 5 and squared, you get 25. If you're asked to find 10 squared, you press 10 squared, you get 100. Now, it's when you come to negative numbers, you've been told that when you multiply two negative numbers, what do you get? Supposed to be positive. Okay, so that same idea applies. If you press negative 5 squared and negative 5 squared, one without the bracket and one with the bracket, you get two different answers. Okay, so to follow the concept where two negative numbers give you positive, you must ensure that any negative number raised to a power must be in brackets. Okay, otherwise you'll be fighting with me. Madam, my answer is negative, negative, negative. Then we check, no brackets. It does alter your answer. Just check this very quickly and see if I'm correct or not. Press negative 5 squared, you get negative 25. But when you use the brackets, you get positive 25. The correct answer is supposed to be positive 25. Okay, especially if the power is 2, 4, 6, and all the even numbers. All right. So that's with regards to the squared key. Let's look at the next one, and this is the cube key. All right. You can find x cubed. 3 cubed is equal to 27. 10 cubed is equal to 1,000. But when it comes to negative numbers, if you use the brackets, you still get a negative answer, because that negative 2 cubed is negative 2 times negative 2 times negative 2. When you multiply 3 negative numbers, you will get a negative answer. Is that clear? Okay. So only with the cube key, if you have to use brackets, remember, as long as the power, if the power is even, then you will expect your answer to be negative. All right. This one here, the funny looking arrow key, can anyone tell me what it's for? Where, yes, it's also for power. You have squared and you have cubed. Any power that's more than 3, this is where you apply the arrow key. All right, it's right here. And suppose if you have to find 4 to the power of 6, you have to press 4, the arrow button, and 6. If you're asked to find 4 cubed, you can use the x cubed button. Don't press 4, arrow, and 3. All right, the cube button is already there. Only if it's more than 3, then you can make use of the arrow button to find the value. So in this case, 4 to the power of 6, that's equal to 4,096. All right, it all seems like very boring stuff right now, but it gets very interesting, especially in the test. Some of you forget how to use the calculator, surprisingly. Then we have the square root key. All right, square root key. If you're asked to find the square root of 9, that's equal to 3. Square root of 64, that's equal to 8. But what about square root of negative 9? Check your calculator, what happens? There's a math error. That's telling us that you can't find the square root of a negative number, square root of a negative number. All right, so keep in mind, when it comes to the square root, you will never be able to find the square root of a negative number. All right, so that's the interesting thing about square root. Now the next one is what goes against this concept right here. Okay, the next key that we're going to discuss will go against what we've just discussed, the cube root key. Okay, so cube root key, you have to press shift and x cubed. Whenever you press shift and x cubed, you're able to get the cube root key. Okay, so this is the cube root key, which finds the value such that when you multiply a number by itself 3 times, okay, say for instance here we have the cube root of 64. You can check, what is the cube root of 64? That is 4. So that means 4 times 4 times 4 is equal to 64. all right? So the cube root of 64 is 4, which means you multiply 4 3 times, you get this number inside the cube root, okay? Right, so like I said, unlike square root, we can find the cube root of a negative number, okay? We can find the cube root of a negative number. Let's say, for instance, cube root of negative 512, the answer that you get is minus 8. So that means minus 8 times minus 8 times minus 8, that gives us a negative 512. So as I've mentioned, it's pretty different from square root. When it comes to cube root, you can find the cube root of a negative number. Is that clear? Any questions? And then we have this funny looking key. We use this when we're asked to find 4th root, 5th root, 6th root, and so on. Okay? How do we access that? Let's say, for instance, 4th root of 81. You have to press the number 4 first, shift, arrow, and then press 81. When you press shift and the arrow, you're able to access this yellow key right here. That is the 4th root or the x root of any given value. Okay? Simple instructions, but then again, in the exam, some people tend to forget. All right? Keep that in mind. 4th root will be, you press the number 4 first, and then shift arrow, and then you press 81. So what would be the 4th root of 81? And that is equal to 3. That's right. Is that clear? Right, so now let's look at something interesting. This is also part of Unit 4 or Topic 4, when you have a number that's raised to a fractional power. When you have a number that's raised to a fractional power, when you rewrite that, it'll be the b root of x, and everything is raised to the power of a. So remember that the denominator goes inside the bracket, whereas the numerator will be outside the bracket. So if you're asked to find a certain number raised to a fraction, you can still use your calculator, but remember, denominator inside the bracket, numerator goes outside. Okay? You'll find more examples in your book, and we'll also try and tackle more questions in our tutorial. Right, so this is the most annoying part of this topic, simplifying square root. Okay, so when we talk about simplifying square root, we do this when we want to simplify the number inside the square root sign. Okay, now keeping in mind, when we talk about, let's say for instance, the square root of okay? When we're asked to simplify numbers such as this, you must consider two numbers that multiply to give you 27. Okay? And as the second point, I mentioned that you have to look for a factor that contains a perfect square. Do you still remember what perfect squares are? No? So I have a table. So choose a number, say 2. 2 squared, answer is 4. 4 is the perfect square. 3 squared is 9. 9 is the perfect square. 4 squared is 16. 16 is the perfect square. So keep in mind, if you have to simplify this type of expressions, you have to look for factors that contain a perfect square. Is that clear? So here we have the square root of 24. I've taken this example from the course book. Factors of 24 are 4 and 6. So 4 is the perfect square. So it's square root of 4 times square root of 6. If I take the square root of 4, that is equal to 2. So in the end, square root of 24 is equal to 2 root 6. The property that we use is this, square root of a times square root of b, that's equal to the square root of ab. We could have used 2 times 12, but is any of them a perfect square? 2 a perfect square? No, it's not. 12, is it a perfect square? No, it's not. That's why we didn't choose 2 and 12. We chose 4 and 6 because which one is the perfect square? 4 is the perfect square. All right? So remember, you have to put the perfect square first, especially when you're simplifying square root. Is that clear? Another example here is square root of 48. All right, 48, we've chosen 16 times 3. What about 4 and 12? Does that give you 48? It does. Okay, but in this case, we could have used 4 and 12, but we try and choose the largest perfect square in this case. Okay, you have 4 and you have 16. 16 is the largest perfect square, so our answer becomes 4 square root of 3. Is that clear? All right, so any questions with regards to topic 4? With other calculations. Now with this, I'd suggest that you refer to the tutorial questions for this week. Week 3 tutorial questions has a lot of these square root, simplifying square root. Okay? Let's see. We have about 20 minutes left. 15. Last one for the day. And this is the last topic as well. What is the last topic? Laws of exponents. Okay, this is the interesting one of them all. And again, it drives everybody nuts. Laws of exponent. What do you know about exponents? Another word for exponent is power. Another word for exponent is power. Okay, so we have a small example here, We have a small example here on the board. 3 to the power of 4 is 3 times 3 times 3 times 3. That's equal to 84. This is usually called the standard form. And this one here, this is known as the exponential form. Okay? Let's go straight. Wait. What did we do? Computers have been giving me a hard time today, so please bear with me. All right. two parts to an exponent. You have the base and the power, or the exponent. And the exponential form is usually it has a base and the power. Okay, sorry. Here we go. Exponential part, or the exponents, it comes in the form of a base and the power. Now the reason why you have to understand this is because when we discuss the laws that come after this, it will only apply if the bases are the same. Okay, so you have to know the difference. What is the base and what is the power? If the bases are the same, then the laws that we're about to talk about here will apply. All right. Now the other thing is, if the base and the power are both numbers, then it's important to make use of what we've just learned in topic 4. Find the value of 5 cubed, and the answer that you get is 125. Okay, so if the base and the power are both numbers, you're expected to find the value. Okay, so this is what we've been talking about. 5 cubed is basically 5 multiplying with itself 3 times. All right, so the first law. When multiplying bases, we're multiplying terms with the same base. The key word that I've highlighted here is keep the base the same, but what you need to do is add the exponents. Okay, what maybe in high school they tell you bases are the same, you add the powers. You've heard that before. This is the same rule that we apply. Right here, x to the power of m is multiplied with x to the power of n. That's equal to x to the power of m plus n. So 2 to the power of 6 times 2 to the power of 3, that's equal to 2 to the power of 6 plus 3. We know that 6 plus 3 is 9. And like I said, if the base and the power are values, then you have to find 2 to the power of 9, and that is 212. So remember, when the bases are the same, you add the powers. With this in mind, I have a few questions up my sleeve. Number 1, see if you're able to answer this. You can write the answer in your book, because I have about 5 more. Just quickly write the answer in your book, and then I'll move on to the next one. Three squared times 3 squared. When you're done, the next one is 5 squared times 5 to the power 4. Try that. And after this, I'll give you the solution, and you can mark your work. Remember what I said, if the base and the power are numbers, you need to find the value. Next one, 8 to the power of 5 times 8 to the power of 2. Just write down what you think is the answer, and then I'll show you the solutions after. Now 2s squared times 4s to the power 7. Number 5. Bless you. Last one. S squared T4, S7 T3. Multiply the two. Remember, we're saying that if the bases are the same, you need to add the powers. Moment of truth. What would be your answer? 3 to the power 4, which is equivalent to 81. 5 squared and 5 to the power 4. 5 to the power 6. What is 5 to the power 6? Somebody? 15,000? Thank you. I think I didn't add that part. Sorry. Next, A5 times A2 is equal to 8 to the power 7. Thank you. All right. Number 4. 2 times 4 is 8. S2 plus 7 is 8 to the power of S to the power of 9. So it's 8S to the power 9. Please mark your work. And number 5, the bases are the same. The power will now be 2 plus 3. That's equal to 5. So negative 3 to the power 5 is equivalent to negative 243. And the last one, S squared T4 times S7 T cubed. What would be your answer? S to the power of 9 and T to the power of 7. If you're able to get this correct, then you're definitely ready for difficult questions. All right, so the next law is when you're dividing terms. The second law, when you're dividing terms with the same base, what happens is you have to subtract the powers. It can be written as a fraction, like this, numerator, denominator, or it can be written as an expression, division. But in the end, whether it be this way or this way, remember that you have to subtract the powers. So the simplest form that I've chosen is 2 to the power 6 divided by 2 to the power 2. You subtract the powers. 6 minus 2 is equal to 4. So 2 to the power 4 is 16. And as always, S to the power 12 divided by S to the power 4. That's the first one. 3 to the power of 9 divided by 3 to the power 5. Remember, dividing terms with the same base, you need to subtract the powers. All right, so s to the power 12 divided by s to the power 4. 12 minus 4 is equal to s to the power of 8. Next one, number 8, 3 to the power of 9 divided by 3 to the power of 5. That's 3 to the power of 4, that's equal to 81. S to the power 12, T8 upon S to the power 4 and T4. That's S8 and T to the power 4. And the last one, 36A5B8 upon 4A4B5. First you divide 36 divided by 4. 9 and A5 divided by A4. A to the power of 1, or A, B8 minus B5, B to the power of 3. So your final answer is 9AB cubed. All right, so any questions? All right, so the remaining rules, we'll try and have a look at that next week. All right, but remember that these questions here, or the slides, are available on Moodle. In case you want to go through them before next week, feel free to do that. Okay? So in this week's class, we are going to look at conversions, topic 4, which is other calculations, and we'll also try and start off with laws of exponent. Okay? So thank you so much for coming today. Next week we'll continue with this, and as well as moving on to the next